Hello. We're going to do topic 2 now. And it's talking about irrational numbers. So I can, for just this first one, 2, 2, I can identify a number that is irrational, right? So couple definitions here to start with. Irrational number is a number that cannot be written as a over b, where a and b are integers. Remember, it's like any whole number, 1, 2, 3, 4, 5, all the way up to a million and whatever, or into the negatives, or zeros even as well. So if I have any number, a over b, then it's an integer, then it's a rational number. Irrational is when it cannot be written like that. So we'll get to that a little bit later, and we'll see what those are. And we're also going to look at square roots now. A number that's multiplied by itself gives us a number. 3 times 3 equals 9. And the square root of 9 gets us back to that original number. Square root of 9 is 3. So, key concept. Numbers that are not rational, they're called irrational. A nice way to think about that is like, if it's something that you would be able to spend a number of minutes writing, like if I was going to write the number 2.5678, that took me a matter of half a second to write that out. That's a rational thought. I'm going to write out this number. If there was a number like pi, where I'm thinking 3.14159.265, blah, 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 on and on into infinity, it is an irrational thought to think that I could write that out. So there's an example, is pi is an irrational number. So we're looking at, down here, we got to, back to our normal videos, we're looking at what is going on with all of these. So Sophia wrote a decimal as a fraction. Her classmate Nora says that her method and answer are not correct. Sophia disagrees. Of course, if you're not correct, I am correct. It says that this is the method she learned. So it's hard to read, but if you got the paper out, you could see this says 0.12111211121112, and then so on and so forth. And then as Sophia was working out her math here, she just wrote it as 0.12. She kind of estimated or rounded. And then she carried out some other stuff to try to figure out what x is equal to. And you cannot do that because she didn't write out the entire thing. So when Nora is telling her that she is wrong, Nora is correct. Because Sophia, her number was 0.12112111121112. Sophia then wrote and just estimated and said, I'll just call it 0.12. Her math then was wrong from there on out because she did not write out that irrational number. So Sophia's correct. What is another non-terminating decimal number that cannot be written as a fraction? An example of that, I just gave it a minute ago, is pi. But right here, this is an example of it's non-terminating. It's going to continue to go on forever. There is a pattern there, but there's no way to easily denote that pattern or say that pattern. And so that number there is what's called irrational. It would take you forever, or it would be an irrational thought to think that you can write out that number to completion. All right, moving on. Example number 1. The Venn diagram shows the relationship among rational numbers. How could you classify this number? So we've got natural numbers, any number that you can count or think of, that are here. 19 is a rational or a natural number. The square root of 4, which is actually 2. 2 times 2 is 4. So the square root of 4 is 2. All whole numbers, 0 is the only addition to that. And then integers, these are numbers that are whole numbers, but they're either positive or negative. There's no fractions in there or no decimals. Even though this one right here says negative 16 over 4, well, that's actually a negative 4. So, and that's a negative 1,000, that's a comma there. So those are the integers. Rational numbers is when you've got decimals and fractions introduced into those numbers, positives and negatives. Now we're looking at what doesn't fit in there. Those are irrational numbers. So how would you classify the number here? 0.24758326. It goes on and on and on. That's telling us it's not going to terminate. It is non-terminating. So this is an irrational number. And that's where our definition comes from. Numbers that are not rational are called irrational. Stands to reason. It's a number if you were to put any of these into a fraction, they are all equal to an integer over an integer, and the denominator or the numerator on the bottom, it is never equal to 0. If you ever have a fraction that has something over 0, the answer to that is it's actually not. It is not equal to 0. It is actually what's called undefined. Undefined means it cannot be put on any sort of number line or graphing line or anything like that. Let me give you an example. If I have 4 cookies and I'm going to divide my 4 cookies, it is impossible to divide them 0 times, because you can't have matter and then divide it never or nothing. You're always going to have to be equal to at least some sort of division has to occur. You can't have 0 division occurring. So that's why that number is called undefined. That will definitely be something you see a ton of when it comes to algebra and calculus. All right, example number 2, we're going to classify the square root of 3. It means the non-negative square root of 3, or instead of saying positive. Square root of a number is when you multiply a number by itself, it equals the original number. So the radical symbol, that's what this stands for. That's the radical symbol. It is used to denote the non-negative square root. So another way to draw squares or square roots is to look at, if I were to make that into a square, what would be the dimensions of that square? So here's some examples. We got 1 times 1. So this is a square that is 1 squared by 1 square. 1 times 1. I've only got 1 block there. What's the area of that? 1 block. So the square root of 1 equals 1. That's going to come in handy a lot when you see stuff It's going to come in handy. This next one, 2 times 2 equals 4. So we've got 2 by 2, and then when you count how many blocks are on the inside, you got 4. The square root of this, what is the sides of my block when I have 4 squares there? Square root, 2. Last one, 3 by 3, 3 times 3, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 squares there. So our square root of 9, what number times itself equals 9 equals 3. These numbers, 1, 2, and 3, they're what's referred to as a perfect square. When you have a number that is the square of an integer, these are integers, 1, 2, and 3. If I tried to think of something between there, what's between 4 and 9? 5. Square root of 5, that does not equal an integer, because it's, 2 and 3, it would be somewhere like 2.2 and on. It'd be an irrational number to think about that. So it is not a perfect square to figure out. So square root of 5 does not equal a perfect square. The first perfect squares, you got 1, 4, and 9 are what are called perfect squares. The next one, 1 times 1 is 1, 2 times 2, 3 times 3. The next perfect square would be 4 times 4, which equals 16. So if I looked at what's the square root of 16, that's back down to this, 4. The next one would be 5 times 5 equals 25. So our square root of 5, square root of 25 equals 5. Okay. Any questions? Yeah, just kidding. Last one. Let's classify each of these numbers and look at, is it rational or irrational? Negative 81,752. That can easily be written over 1, but it's also, I mean, it's just a plain old negative whole number. So that is considered rational. The square root of 11, I just wrote it up here. If I were looking at the square root of 9, our next one was 4 times 4 equals 16. So our square root of 16 is our next one, equals 4. So this one is irrational. And if we were going to carry it out further, this will be another few topics down the road. We can say, if we're going to estimate it, that this is negative 9, or the square root of 9 is less than the square root of 11, which is also less than the square root of 16. So we're estimating, we're going to say that square root of 9 is 3 is less than the square root of 11. And the next one was 4. So we're saying that the square root of 11 is somewhere between 3 and 4. That's an estimation. That'll be in a few topics, but that's it. So the answer there is rational, irrational. Here's another one that's a pattern that's forming. It would be irrational for me to try to write this number out all the way to then therefore be able to put it into a decimal. So it's irrational. I already gave you into that one. The square root of 16, that equals 4, which is a whole natural rational number. So it is a rational number. The end.